Understanding Pre-Harvest Agricultural Water. This video explains the updated FDA rule on pre-harvest agricultural water under the Food Safety Modernization Act, Produce Safety Rule. The updates make compliance more flexible but require proactive risk assessments. Testing is now optional to support management decisions.
Before we get started, let's recap. The Food Safety Modernization Act, Produce Safety Rule, sets standards for safe produce. The pre-harvest agricultural water section was updated to replace mandatory routine testing with a systems-based approach to identify biological hazards in pre-harvest water. Today, we will break down assessments, inspections, and how to assess risks based on likelihood and severity of contamination to help you implement safe farming practices.
Welcome to our course. Today, we'll dive into how to evaluate the key pieces of your agricultural water assessment under the rule. By breaking down the 5 main elements of an assessment, such as crop characteristics, application methods, timing, and weather, you'll learn to assess risks effectively and keep your produce safe.
What is an agricultural water assessment? Well, friends, you are in the right place to find out.
The purpose of this assessment is to identify conditions that could introduce hazards, such as fecal contamination, into agricultural water sources used for pre-harvest or growing activities. By identifying these risks, you can determine if corrective actions or mitigation measures are necessary to prevent produce contamination. This annual assessment is a holistic, big-picture review of your growing practices. You will evaluate various factors to determine potential risks, implement management strategies to reduce those risks, and apply corrective actions or mitigation measures as needed to address contamination events. Start by mapping your system and determine the degree of protection. Then, note how water contacts your crop and identify any vulnerabilities. These factors can include characteristics of the crop being grown, environmental conditions such as weather events, and other relevant factors like water testing results or historical data.
Risk is likelihood times severity. For example, runoff from nearby manure increases likelihood. Crop damage from hail boosts severity. Here are the key points. What is the likelihood? The likelihood is the probability of hazard introduction. Example, it would be high if open canals are near animal grazing, but lower if barriers are used as a preventative measure. What is the severity? This is the potential impact of contamination. It is important to evaluate risk using a scale such as low, medium, and high for overall risk. Factors could include proximity to hazards or weather triggers causing susceptibility of the crop. Using a risk matrix grid can help with your evaluation. Let's take a look.
The graphic on the slide shows an example of a risk matrix grid, which can be used to help you assess individual elements of your agricultural water assessment. During your evaluation, first ask yourself, based on the environment and management practices, how likely is contamination to occur? Then ask yourself, if the water source becomes contaminated, what is the potential impact on produce and public health? If it is rare that contamination of your water will occur and will not be considered significant at all because you use drip irrigation, then the rating could be a 1, meaning a low risk. If it is certain that a hazard was introduced and the impact will be serious for consumers and widespread contamination of the produce, then the rating would be a 5, meaning a high risk. Notice the green color is associated with low risk and therefore indicates minimal oversight and monitoring. The yellow-orange color is associated with a moderate risk, which indicates that the impact or likelihood is now elevated, therefore it requires a management strategy to help reduce the associated risk. The red color indicates a high risk, and immediate action should take place to mitigate the risk. The goal of the agricultural water assessment is to keep water sources out of the red. Now let's review some examples.
There are factors that increase the likelihood of contamination of your agricultural water, such as using surface water sources, your proximity to livestock or manure operations, upstream urban activity or wastewater facilities. Some factors that could decrease the likelihood would be using groundwater sources that are properly maintained. The goal of the assessment is to keep your water out of the red or high-risk zone. Keep in mind that direct contact with covered produce has a severe impact if the water is contaminated, because the produce is consumed raw, meaning a pathogen could survive until consumption. But remember, using effective water management strategies will reduce the chance that contamination will occur.
Based on the risk identified in your agricultural water assessment, select the following time frame to correct the issue. Red is high risk and needs an immediate correct action. Orange is medium to high risk, requiring mitigation during the current season. And yellow is a medium risk requiring changes no later than the following season. The associated time frame to implement either a corrective action or a mitigation measure is determined by the level of risk severity. Example mitigation measures could include changing your method of application, changing your water source from surface to municipal water, extending the time between application and harvest, treat the water or other strategies to prevent contamination.
Now that you know how to determine risk by assessing the likelihood and impact of the identified conditions, let's focus on the required elements you need to evaluate to complete your assessment.
The first element required to assess is your agricultural water system. It is required to conduct an inspection of the location, water source, type of water distribution system, and degree of protection. Remember to use the risk assessment matrix shown on the previous slide to identify likelihood versus impact.
The second element requires you to assess application methods and timing of the application. It is important to understand what is considered a lower risk compared to a higher risk. For example, surface water is open to the environment, increasing the likelihood of contamination. If you are directly applying your water up until harvest, that can increase the impact.
The third element requires you to evaluate the crops you are growing. Think about the factors that could make your crop more susceptible or less susceptible to contamination. Some factors to consider are surface area, roughness, fragile skin, waxy texture, or growing method.
The fourth element is environmental conditions and significant weather events such as heavy rain, UV light exposure, hail, frost, wind, or dust. Notice how environmental conditions can impact the susceptibility of the crop. For example, frost can cause blistering, which can make the produce item more susceptible to contamination due to the damage of the epidermis.
The fifth element includes other relevant factors which could assist with your assessment and associated management practices. Some relevant factors to consider include water testing results, historical data, adjacent land use or upstream activities such as recreation use or sewage discharge.
Let's recap. Corrective actions are used in circumstances where it is necessary to take immediate action to protect public health. Farms must implement corrective actions in order to resume use if the water is unsafe for pre-harvest activities. Mitigation measures can be flexible, unless the risk is associated with animal or human waste activity or involving human waste. It is required to take mitigation measures during the same season.
Document all system inspections of the water distribution system, the elements evaluated in the assessment including the risk assessment conducted for each factor, and any supporting documentation such as water test results. Remember, record keeping is required by the rule and will be reviewed during your PSR inspection. You must retain records for a minimum of 2 years. To wrap it up, thorough evaluation helps identify and prevent contamination. To determine risk, you must evaluate the likelihood contamination occurs and the associated impact of the contamination event. Evaluating the 5 elements empowers you to manage risks proactively and meet the requirements of the regulation. Stay compliant and safe. Thanks for watching.